Hello, students of science. Let's talk about electromagnetic induction, how electricity is created and used from generators and motors. So, just to review, we've previously talked about how electric and magnetic force are essentially the same. A generator is how you use magnets to create electricity. So if you were to turn this crank, you would essentially get that to light up there. And it's also electromagnet is kind of the inverse. It's electricity that creates a magnet. So remember, they are one and the same. It just depends upon what's the input and what's the output. So this is an example of something called an eddy current. You can essentially take a conductive pipe, in this case a copper pipe, and drop a magnet down through it, and it's falling. It's not slow motion. That's actually real time there. It has to do with the electromagnetic induction, how electricity and magnetism are kind of one and the same. As that falls, it's actually creating small electrical currents in the metal, and those are in turn sort of slowing its passage through there. Very cool. There's also something called electromagnetic induction heating. Now this is kind of a video that got turned into a GIF form. If you want to see the entire thing, I'd say click right up here. It's a very cool video, and this has been sped up a little bit. And it is levitating, as you saw before, but they are running electricity through this, back and forth, alternating current, and it's actually able to heat this thing up to very, very high temperatures. And you drop it, and it turns back into metal there, into solid metal. Very cool. Check out that video. Electromagnetic induction is the process of generating current by moving a magnet inside a loop of wire. A generator is a device that converts kinetic energy into electrical energy. So here we have a wind turbine, and as this rotates, it's going to turn what's more or less inside there. Eventually, you're going to have a magnet wrapped lots and lots of times with a loop of wire. As that magnet is actually moving around and around and around inside that loop of wire, electricity is generated. This is how a wind turbine is actually going to take kinetic energy and convert it into electrical energy. Most power plants use some type of generator to electricity to your home. The electricity that you're listening to this with probably came from something just like this. At some point, there was a magnet inside a loop of wire, and as it rotated, electricity was created. Get it? Renewable energy? I'm a big fan. Because more or less, you get this giant thing right here. It's a wind turbine, and of course, kinetic energy converts into electrical. But if you were to run it backwards, you could run electricity into this and turn that into a motor. So it's a big fan. Get it? All right, so I want you to make two columns, one for generator and one for motor. So a generator, something that you might need to power your house or a hospital in the event of a power failure, the input is going to be mechanical energy, so kinetic energy. You know, that might be just a motor in there that's going to be spinning that magnet. The output is going to be electricity in a generator, because that's the whole point. You wanted the electricity. Here we have roughly the kind of concept here. In this case, water is flowing through here, and as it's going to drip down, it's going to cause that to rotate. That rotation is going to generate electricity, and there's the generator right there. So the input is mechanical energy, the output is electricity. A motor is going to be different. What you put into it is going to be electricity, and what you get out of it is rotation. You're going to get mechanical energy. Here we have roughly a motor right here. So electricity is going in, and it's going to cause this thing to rotate around and around and around. So generators, sometimes there's another fuel like diesel or gas is burned in order to transfer that chemical energy into mechanical energy first. But in the end, we need to make mechanical energy because that will get converted into electricity. With a motor, sometimes you can start with a battery where you're going to be using chemical energy, converting that into electrical energy. That's what's going to convert it eventually into our output there. Examples of generators: power plants, your car has a generator, diesel backup generators. Examples of motors: fans, cars, blenders, all those things. You put in electricity and you get out mechanical energy. Let's do a drawing of how a nuclear reactor roughly works. So we're going to start here with the radioactive symbol. This is, of course, where the radioactive material is going to be in, and it's going to be in a large container called a radioactive vessel, or nuclear reactor vessel there. There, of course, you're going to have water that is going to be pumped in, usually from a nearby lake or river, and it's going to be pumping in cold water in very, very close proximity to where the nuclear fissile material is actually going to be. And of course, the whole idea here is that this is going to release a great deal of energy in the form form of heat. So you have this cold water entering, and of course, when you heat that up to a great deal, you're going to turn that water into steam. And of course, steam wants to escape. And essentially, they're going to let it escape, but they're going to make it go through a turbine, a very, very large fan. And it's going to go from there to what everyone is very familiar with, the nuclear cooling towers. That's, of course, where the steam is going to be cooled off a little bit and escape into the atmosphere. But not before doing what was the whole point of this, and that was to spin that turbine very, very rapidly. That turbine is going to be hooked up to a generator, and it's, of course, going to be rotating. And I'm obviously simplifying this whole drawing a little bit, in case you hadn't caught on. But the whole idea here is that that turbine is going to be turning a generator, and inside there we're, of course, going to have a magnet. And, of course, if you want to generate electricity, you have to have that magnet rotating in a coil of wire. When you have a magnet rotating in a coil of wire, that is where you're actually going to get your electricity generated. So this is where it's going to be making it, and of course this is where the power lines are going to be coming off of, and there's very, very large power lines that go through here. But this whole rotation inside a coil of wire is where you actually get electricity being generated. That's the whole point. All this here is set up to spin the turbine so you can spin the magnet inside the wires. That's electromagnetic induction. All right, as you just saw in that drawing here, here's obviously a little bit better schematic, but more or less we have cold water coming into here that's pumped into our nuclear control rods. That's where all that heat is generated, and yet this very, very high temperature steam, it's going to be pushed out, but before it escapes, it goes through the turbine. And then remember this giant fan, and eventually that will be recondensed or evaporated back into the atmosphere with the cooling towers. But as this rotates, it's going to move. Inside there will be a magnet wrapped in a coil of wire. As that rotates, it creates electricity that you use to power your house. So the energy cycle, and I want you to put this on the same page where you had your drawing. You start with an energy resource. And a lot of times, not always, but a lot of times you're going to heat that water into steam. But here's the part where they all come together. All of that is going to turn a turbine. You have to essentially turn a giant fan, something that's going to rotate. As it rotates, it's going to signal that generator to create electricity. So here we have one of those giant turbines that you might see at the bottom of a dam. Very, very large turbine blades. As the water goes through there, it causes it to rotate. And here is roughly an idea of the size and scale of some of these turbines. They are big. So the turbines will turn a magnet inside a loop of wire, a generator, and this causes the electricity to flow in our generator. This is how we turn kinetic energy, rotational energy, into electricity. That magnet inside a loop of wire. Coal power plant works basically the same idea. We take another energy resource, you burn it, and you heat up that water into steam. That steam turns a turbine, and of course that turbine is hooked up to a generator. Magnet inside a loop of wire causes electricity to flow out to your house. Other renewable energy ones, we have geothermal, where it's going to inject water down into the earth, have the earth heat it up, and then pull out that superheated steam, turns a generator, magnet inside a loop of wire. Here's a dam. The gravitational potential energy of the water is going to cause that turbine to spin. Of course, turbine hooked up to a generator, magnet inside a loop of wire. Here we have just a basic wind turbine here. It's going to cause it to spin, and there we have our generator, magnet inside a loop of wire. Common thread here.